Okay, so today we're on page 215, and we're going to be talking about geometric series. We already learned about arithmetic sequence, arithmetic series. Last class we did geometric sequence, but we did not do geometric series, okay? So we got to add that on into our notes. Remember, series is when you're finding the sum of the sequence, okay? So just like with a finite arithmetic series, remember finite's like the opposite of infinite, arithmetic series, you can find the sum of a finite geometric series using a formula. You need to know the first term, the number of terms, and the common ratio. A geometric series is the sum of the terms, of a geometric sequence. And the formula is S sub n equals a sub 1, open parentheses, 1 minus r raised to the n, close parentheses, all divided by 1 minus r. A sub 1 is the same as it's been in the others. It's the first term. R is still a common ratio. N is the number of terms in the sequence. So not the term number we're referring to, but how many terms do you have in the sequence? All right, let's look at an example. Am I going too fast? Y'all caught up? All right, so first example, what is the sum of the series? I have 3 plus 6 plus 12 plus 24 plus dot 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 plus 3072. Okay, so we know we need to know the first term. We know that. We need to know the common ratio is what? 2. We also need to know how many terms are in the sequence. Do we know how many terms are in the sequence? No, they did not give us that information. So we're going to have to figure out how many terms are in the sequence, okay? So what we can do is, we're not going to be able to start with the geometric series formula. We're going to have to use the explicit formula that we used in the last class to figure out how many terms are in the sequence, and then we can take that and then we can use the geometric series formula, okay? So I'm going to write out a little explanation so that you have that. We know a sub 1 is equals 3 and r equals 2, but we don't know how many terms are in the series. We could write them out and count them. Or we could use the explicit formula to solve for n. In parentheses after explicit formula, I'm going to put geometric because arithmetic has its own explicit formula. Remember, the explicit formula is when you're looking for a particular term. So that's what I'm going to do first. So that explicit formula was a sub n equals a sub 1 times r raised to the n minus 1. So remember, in the explicit formula, a sub 1 is the first term. We know that. R is the common ratio. We know that. N is the term number you're looking for, or you can think of it as the term number you're referencing. Well, I want to know how many terms are in the sequence. I know what the last term is. I just don't know what term number that is. Is that the 50th term? The 20th term? What term is it? So I'm going to use this term for a sub n, but I don't know what term number it is, but I know all these other variables that I can substitute in for and just solve for n, okay? And then that will tell me this is the 50th term or 100th term or whatever term that it is. So that will be, this is the term number, this is the last term in the sequence, which is usually what we're, well, erase that. A sub 1 is 3 times the common ratio is 2 raised to the n minus 1. Now, my variable that I'm solving for is in my exponent, okay? So for now, can I multiply that 3 and 2 together? No. I want to solve for n, it's in the exponent. Can I get rid of this 3? How would I do that? Divide both sides by 3. 3,072 divided by 3 is 1,024 equals 2 raised to the n minus 1. Okay, this is an exponential equation. I've got a variable in the exponent. So I can try to write both sides with the same base, or I could rewrite this as a logarithm, because that's why we learned logarithms, okay? Which to me, instead of figuring out what 2 raised to the what's 1,024, if it's even possible, I'm just going to write it as a logarithm. So that would be log base 2 of 1,024 equals n minus 1. We just took a test over this. Can I evaluate log base 2 of 1,024 in my calculator? Yeah, change the base, right? We got to make sure you put it in correctly. So log, what number goes first? 1,024. Don't forget to close parentheses. Divide by log of 2. And I get 10. So 10 equals n minus 1. Of course, I have to add 1 to both sides. And n equals 11. So that tells me that 3,072 is the 11th term in the series. So there are 11 terms in the series, okay? I have to know that before I can use the geometric series formula. So now we know a sub 1 is 3, r is 2, and now we know n, which is how many terms are in the sequence, is 11. And we can use the formula that we wrote above. So I'm looking for the sum of the first 11 terms. So I'm looking for S sub 11. The sum, add them all together. So I take my first term times, open parentheses, 1 minus the common ratio of 2, and only the common ratio is being raised to the 11th power. That exponent is inside the parentheses, not outside the parentheses, okay? Over 1 minus 2. So that gives me, let's simplify inside parentheses first. 2 to the 11th power is 2,048. So that's going to be 1 minus 2,048, correct? I'm running out of room, so I don't have space to write all this down. So that's 3 times negative 2,047 over 1 minus 2 is negative 1. Multiply my numerator together, so negative 2,047 times 3. I get negative 6,141 divided by negative 1. So basically, you're dividing a negative divided by a negative, and my 11th, the sum of the first 11 terms is 6,141. That's not the 11th term. The 11th term is 3,072. That's if I added the first 11 terms together, I would get 6,141. Coolio? Any questions about that? Am I still writing? Okay, 216. Evaluate the sum of the series. I have 4 plus 12 plus 36 plus 108 plus ... plus 972. I know a sub 1 is 4. I know my common ratio is what? 3. Because 4 times 3 is 12. 12 times 3 is 36. 36 times 3 is 108. But do I know n? Do I know how many terms are in the sequence? I don't, right? So again, I'm going to have to use the explicit formula to figure out how many terms are in the sequence before I can add them all up. All right, so again, n's the term number we're looking for. In this case, I'm going to use my last term. I don't know what term it is, but I know that my last term is 972. So for a sub n, I plug in 972 equals my first term is 4, common ratio is 3, raised to n minus 1. I don't know what n is. I don't know what term number that is. That's what I'm trying to find. So again, my variable's an exponent, so I need to get it in exponential form. So to do that, I'm going to divide both sides by 4. 972 divided by 4 is 243 equals 3 raised to the n minus 1. Now you can try to write both sides with the same base if you want, or you could just go ahead and write it as a logarithm. So as a logarithm, that would be log base what? What would your base be? 3 of 243 equals n minus 1. Then I can just use a little change of base. Log of 243, close parentheses, divided by log of 3, and I get 5. So 5 equals n minus 1. Go ahead and add 1 to both sides, and n equals 6. So now I know that there are 6 terms that I'm adding together, and now I can use the other formula to figure out the sum of those 6 terms, right? All right, so take that formula, and n is 6. I'm looking for the sum of the first 6 terms. So I take the first term, open parentheses, 1 minus the common ratio, raised up to 6, divided by 1 minus the common ratio of 3. So I have a little more room this time. I can show my work. So it's going to be 4 times 1 minus 3 to the 6th power. 3 raised to the 6th power is 729. Over 1 minus 3 is negative 2. So that's 4 times 1 minus 729 gives me negative 728 divided by negative 2. Simplify my numerator. 4 times negative 728 is negative 2,912. Divide that by negative 2, and the sum of the first 6 terms of the sequence is 1,456. Anybody have a question on that? All right, on the next one, I'm going to let y'all try to do it on your own. And then we'll check it. And then we'll move on. Something else. Just make sure you got it. We'll move on to a summation and notation. Alright, so try this one on your own. Going to find the sum of negative 5 minus 10 minus 20 minus 40 minus 2,560. Do that on your own. I'll freeze the screen and work it on my own, and then we'll compare. What's that? Yeah. Yeah. Anybody get the answer? What'd you get? Negative 5,115. Did anybody else get that? That's what I got. Good job. So when you did the first part, the explicit formula, you found out there were 10 terms, right? So if that was incorrect, then obviously the rest of your answer was incorrect. So then you plug that into the sequence formula, and then you can see my math. Oh, sorry. Yes. So do anybody need to see the explicit formula? Okay, so here is sequence. We have a question? Negative. As you add all those negatives together, it'd be negative, right? So the answer was negative 5,115.
Excuse me?
Yes?
Do you have Travis Douglas?
He's not here today.
Thank you.
You're welcome. Up. Oh, like down. Up as in down. Are we good? Am I confused about any part of that? Okay. On page 218, so now we're switching to something called summation notation. Maybe, I know a lot of y'all have been taking the ACT and SAT. I don't know if it's on there or not, but maybe you've seen something like this and it's like, what in the world is that? And in case you have, well, after tonight, you will know. So page 218. This is called summation notation. All right, and there's arithmetic and geometric summation notation. So we're doing the arithmetic first. So remember, in arithmetic, that's when you have a common difference, not common ratio. You're adding the same number to get to the next term in the sequence, where geometric, you're multiplying to get to the next term in the sequence, right? So we're back to arithmetic. All right, you can use the Greek capital letter sigma. You can use the Greek capital letter sigma, which looks like this, to indicate a sum . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . period. With it, comma, you use limits to indicate how many terms you are adding. Period. Limits are the least and greatest values of n in the series. You can write limits below and above the sigma to indicate the first and last terms of the series. Okay, some more Greek letters. Remember in the unit circle we had theta, that was a Greek letter. Now we have sigma, another Greek letter. So my first example says, what is the summation notation? And we have -5 plus 2 plus 9 plus 16 plus 261 plus 268. Okay, first of all, is this arithmetic or geometric? Arithmetic. What number am I adding every time to get to the next term of the sequence? 7. So plus 7, not times 7, plus 7. So that tells us it's arithmetic. So if I'm writing an arithmetic notation, first thing you do, first I'm just going to show y'all how to write the notation, and then I'm going to show you how to, if you're given the notation, how to find the sum of the series, okay? But first I'm just going to show you how to write it and what each part means. So you kind of write like a big, I'm writing it big so that I can like point out my parts. A big sigma. So the top, we're going to write a number up here. And that represents your upper limit. We're going to write a number below sigma, and that represents your lower limit. And then we write a number out to the side, or expression, and that comes from the explicit formula. Okay, so over here on the side, I'm going to use the explicit formula to find out how many terms are in the sequence. This will be the upper limit. So remember, arithmetic and geometric, they have different formulas. So if we're using the explicit formula for arithmetic, that is a sub n equals a sub 1 plus, open parentheses, n minus 1 times d. D is my common difference. And I just want to figure out how many terms are there. Number 268 is what term in the sequence. Okay? So, I don't know what term 268 is, but I want to know what the n value is at term 268. So I'm substituting in a 268 for a sub n. And then I'll just solve for n, okay? Usually explicit formula, you use it like, tell me what's the 10th term, what's the 50th term. But I don't know how many terms. I'm not looking for that. I just want to know what term number is this, so that's why I use that for a sub n. So my first term is negative 5 plus, I don't know what n is. And what is d? 7. So that's 268 equals negative 5. I know that 7's written behind the parentheses, but I'm distributing it. So, and then if I distributed the positive, that would all be positive. So 7 times n is 7n. 7 times negative 1 is negative 7. Combining like terms, that is 268 equals negative 5 minus 7 is negative 12 plus 7n. I will add 12 to both sides. And that gives me 280 equals 7n. Divide by 7, and n equals 40. There are 40 terms in the sequence. Therefore, 40 is my upper limit. Okay, so above sigma, you write a 40. That means I'm finding the sum of the first 40 terms of the sequence. Now, below it, that's where I'm starting from. I'm going to start with the first term, so I do n equals 1. Sometimes if they give it to you already, they give you n equals 0, and that's fine. It may not be 1. Usually you either see it as 0 or 1. Okay, if they don't tell us, we're just going to put n equals 1. But if they give it to you, it might be something different. Now for the explicit formula, over here, we're not using this explicit formula. We use this number to figure out how many terms were in the sequence, okay? But when we're using the explicit formula here, we're using it for the whole entire sequence. So we're not going to use that 268 as our a sub n. So what you do is, and this part is probably where the kids get most confused, so this is the explicit formula part that I use to find this part right here, okay? So it's the same formula, a sub n equals a sub 1 plus, open parentheses, n minus 1 times d. I'm not trying to find a particular term, okay? So for the explicit formula for summation notation, you don't substitute anything in for n. You only substitute in your first term and your common difference for summation notation, okay? It's like you're trying to find the formula, basically. So, only substitute numbers for a sub 1 and d. Then simplify as much as you can. So a sub n equals, my first term's negative 5 plus n minus 1 times 7. Now you're just going to simplify that as much as you can. So again, I'll distribute that 7. So negative 5 plus 7 times n is plus 7n, and then minus 7. And that would be 7n minus 12, or you could say negative 12 plus 7n. Either way. I can't simplify that any further, right? Unless I'm substituting in a number for n, but for the summation notation, that part you don't. You just substitute in a sub 1 and d. So right here, to the side of sigma, I'm going to put 7n minus 12. That's kind of like the formula to find out the term number in the sequence, okay? So if I want to know the third term in the sequence, I would do 7 times 3 minus 12. Let's see if that works. 7 times 3 is 21, minus 12 is 9. Was that my third term in the sequence? Yeah. If I want to know the second term in the sequence, for n, I'd plug in a 2. So 7 times 2 is 14, minus 12 is 2. If I want to know the first term of the sequence, 7 times 1 is 7. 7 minus 12 is negative 5. This is the 40th term in the sequence, right? So 7 times 40 is 280, minus 12 is 268. So this is like the formula for finding whatever term number that you want in the sequence, okay? So sometimes you'll see it as 0. So that just means 7 times 0 is 0. 0 minus 12 is negative 12. All right, whatever the starting place is, it's 0 or 1 typically. All right, if you're adding the 5th term through the 40th term, then that would be a 5 and that would be a 40, and that's okay. You're not adding the first 1, 2, 3, 4 terms, okay? So that's summation notation. So when you see it, this is the upper limit, the lower limit, and this is the explicit formula. It just tells you how to find whatever term you're looking for. If I want the 15th term, 7 times 15 minus 12, now it'll give me the 15th term. It doesn't add them together. It just tells me whatever term I'm looking for. Okay, hopefully, I want to tell you how to read that too. And I'm kind of out of room, but I'll write it over here. So how you say that is the sum of the sum of 7n minus 12 for values of n from 1 to 40. The sum of 7n minus 12 from values of n from 1 to 40. Coolio? All right, page 219. Given a summation notation. Find the sum of the series. So this time they're going to give it to us, okay? So how you would say that is the sum of 2n minus 1 for values of n from 1 to 5. So if it already gave us a summation notation, and it wants us to find the sum of the series. Okay, so first of all, we have to be able to look at this and know, is that arithmetic or geometric? All right, well, either we can find each of the terms of the sequence, or because this is linear, 2n minus 1, my highest degree is a 1, right? If I graphed y equals 2n minus 1, that would be a line. My highest degree of the variable is a 1. So if this is linear, then you know it's arithmetic, okay? That's important to put in your notes. Since the explicit formula is linear, we know the summation notation represents an arithmetic sequence. So if I want to find the sum of an arithmetic sequence, the formula is S sub n equals n divided by 2 times, open parentheses, a sub 1 plus a sub n. So I need to know my first term and I need to know my last term in order to be able to use this formula, right? Well, I don't know any terms. I could plug these in and figure it out, which that's what I'm going to have to do. So I need to find out what my first term is. I need to figure out what my fifth term is. So I'm just going to use some little math over here. First term, we're going to substitute in the lower limit. Into right here, 2n minus 1. That's all we have to do. So into 2n minus 1, that will be 2 times 1 minus 1, which is 2 minus 1, which is 1, as you said. So a sub 1 is 1. That's my first term. For this arithmetic sequence, I need to know the last term. With my upper limit's 5, the fifth term is the last term, right? So to find the last term, I'll substitute the upper limit, which is 5. That's the fifth term. So for 2n minus 1, that will be 2 times 5 minus 1. 10 minus 1 is 9. So my last term, my a sub n is 9, or technically that would be my a sub 5 is 9, right? A sub n is talking about the last term. In this case, that is the fifth term. So now I have everything that I need to know to use this formula. So I'm finding the sum of the first 5 terms. N is 5. So 5 divided by 2, open parentheses. My first term we found was 1, plus my fifth term is 9. So 5 divided by 2 is 2.5 times 1 plus 9 is 10. 2.5 times 10 is 25. Everybody cool with that? Okay, now if you have a problem where the n is 0, like on the last one, n was 1 and the upper limit was 5. So there's 5 terms in the sequence, the first, second, third, fourth, and fifth term, right? That's easy. But when n is 0, that kind of throws you off. If n is 0 and your upper limit's 30, how many terms are in the sequence? 31 terms. We're just going to put that in our notes because that's what we do. We write everything down. But that's what kids always forget. They just look at that upper limit and think that's how many terms there are. But if it starts at 0, then that's technically 31 terms because you have to count the 0 term, first, second, third, all the way up to 30. So if your lower limit is not 1, to figure out how many terms are in the series, take the upper limit subtract the lower limit, and add 1. So if you had the sum of 5n minus 3 for values of n from 0 to 30, and you need to know how many terms there are, it says take the upper limit, subtract the lower limit, and add 1. So 30 minus 0 is 30, plus 1 would be 31. Or say you had the sum of 2x minus 1 for values of n from 3 to 27. That's a 3. 3 to 27. Take the upper limit, subtract the lower limit, and add 1. So that would be how many terms? 25 terms. Let me see if I can get 2 more in, and I'm not going to give you homework. Page 220. Find sum of series. Oh, I don't use back sides anymore. The sum of 3n minus 4 for values of n from 1 to 10. All right, we know this is linear, so we know it's going to be an arithmetic series, right? So I'm adding the first through the 10th term together. So I know I have to use the sum of a series formula. And it's arithmetic because I have to use the arithmetic sum of a series. So I need to go and figure out what my first term is and what my last term is. So I'm going to use the upper and lower limits. So to find the first term, you substitute in that lower limit, right? And I'm going to go kind of fast. And I substitute it into this part of the explicit formula. So for 3n minus 4, that'll be 3 times 1 minus 4, which is negative 1. So my first term is negative 1. To find my last term, I substitute in the upper limit, which is 10, into this explicit formula. For 3n minus 4 n's the 10th term. So the 10th term of the sequence is 26. So by a sub n is 26, or you could think of it as your a sub 10 because it's the 26th term of the sequence, right? So now I have all of the information that I need to find the sum of this series, the first term through the 10th term. So I'm looking for the sum of the first 10 terms. So now I know n is 10. My first term is -1 plus my last term, or my 10th term, is 26. So that's 5 times -1 plus 26 is 25. Multiply those together and you get 125. The sum of the first 10 terms is 125. Any questions on that? One more. Find the sum of the series. So I have the sum of 5n plus 3 for values of n from 1 to 70. Again, because this is linear, we know it's arithmetic, right? So we need to figure out the first term and the 70th term. That's the first term of the sequence and the last term of the sequence. And this time I substituted into 5n plus 3. So my first term is 8. And the last term will be my 70th term. So I'll substitute 5 times 70 plus 3. 5 times 70 is 350 plus 3. So 353. My 70th term is 353. Also known as my a sub n is 353. Now I have what I need. I can use my formula to find the sum of the first through the 70th term. And I'll just do this quietly. Y'all can do it on your own. Just check with me every so often. Any questions on that? All right.